The amount of salt in a salt container in grams is approximately normally distributed. Right, so as soon as I see that, I draw myself a normal distribution, and then I put my mean of 756, and then I split that into 3 sections. I tend to make them fairly wide simply because my handwriting is pretty big, and a standard deviation of 2 grams. All right, so 756, 758, 760, and 762. So 56, 58, 60, 62, and then 754, 752, and 750. All right, I just do that as a matter of course, because we know that the mean is that middle number here, and the standard deviation just means that each of those standard deviations go up by 2. In a random sample of 1,000 of these salt containers, the number of containers expected to contain less than 750 grams. Whew. So less than 750 grams. Now, if you've got that diagram, you'll know that that is equal to 0.15% of my whole data. All right, so I now need to find 0.15% of 1,000. So 0.15 divided by 100 to turn it into a decimal, times it by 123, gives me 1.5. All right, so in a random sample, the number of containers expected to get less is closest to, in that situation, 2 would be the answer that I would suggest was correct.